Today I am going to explain about IPv4 addresses, their size, address space, and the common ways of representing IPv4 address. So first we have to know about that what is mean IPv4 address. So here IPv4 it means Internet Protocol version 4. So IPv4 address is a logical address assigned to a device connected to one IP network. It is used to identify a device and communicate with other devices in the network. So on IPv4 address, it is a 32-bit long. Each 32-bit is divided into four groups of 8 bits. It is called octet. So each and every group it contains 8 bit. So the 8 bit, the name we call it as octet or byte. And again, the IPv4 addresses are unique and universal. So in this IPv4 address, the total address space of IPv4 is 2 to the power 32. Actually, here in general, we mention it as 2 to the power n. The n is nothing but number of bits used in that internet protocol. Here it is version 4. So the address bit, the length of the IPv4 address is 32. So here the n is 32. 2 to the power 32 is approximately 4.29 billions of combinations are possible here. That means we are assigning 4.29 billions of systems to the network here. So this is the total address space of IPv4. The next notation used here in IPv4 is binary notation and dotted decimal notation. Binary notation means the address is written using only in zeros and ones. So here the four octets 32 bits are written only in zeros and ones. Dotted decimal notation means the range of the dotted decimal notation is 0 to 255. So here how we can convert the binary notation into decimal dotted notation means in the first octet there are 8 bits are there. So out of that 8 bits, the first bit is 1 and the remaining 7 bits are 0. So first here we have to know about the place value of each and every bit. So the place value of the last bit is 2 to the power 0, 2 to the power 1. The next bit is 2 to the power 1 and next bit is 2 to the power 2, 2 to the power 3, 2 to the power 4, 2 to the power 5, 2 to the power 6, 2 to the power 7. Total 8 bits are there. Here we start with 2 to the power 0. So here it ends with 2 to the power 7. So this is the place value of all the 8 bits. 2 to the power 7, 2 to the power 7 is equal to 128. The other bits are 0. So here only the one bit, 1 here it is in the place of 2 to the power 7. So the value of 2 to the power 7 is 128. We can write it as in decimal it is 128. Similarly, in the second octet, we have to check in which place value ones are available. 2 to the power 0, 2 to the power 1 and 2 to the power 3. All the three places have only 1. The remaining places, the values are, the bits are 0 here. So 2 to the power 3 plus 2 to the power 1 plus 2 to the power 0. We have to add these 3 bits. 2 to the power 3 is 8 plus 2 to the power 1 is 2 plus 2 to the power 0 is 1. So 8 plus 2, 10, 10 plus 1, 11. So here we can convert this octet in decimal, it is 11. Similarly, here in the third octet, the 1 is placed in the last 2 bits. That is 2 to the power 0 and 2 to the power 1. So 2 to the power 0 is 0, 1 and 2 to the power 1 is 2. So 2 plus 1 it is 3. So the third octet it is converted into 3 here. Similarly, in the last octet, last 5 bits are 0. That is 2 to the power 0 plus 2 to the power 1 plus 2 to the power 2 plus 2 to the power 3 plus 2 to the power 4. Actually, the 2 to the power value is 16 and 2 to the power 4 is sorry, 0, 1, 2, 3, 4. Yes, it is 16. 16 plus 8 plus 4 plus 2 plus 1. So the total number of this value is 31. In this way, we are converting the binary notation into decimal notation. In binary notation, for each and every octet, we leave some spaces. But in dotted decimal notation, from the name itself, we know for each and every octet, we can convert it into decimal. Afterwards, we can put one dot here. So in this way, we represent the dotted decimal notation. So next, already we know the IPv4 address is 32 bits long. In decimal, we can mention it as 0 to 255. But in binary, we can mention it as zeros and ones. So IPv4 address, it is unique and universal. So IPv4 addresses are unique and universal. So how we can say it is unique and universal means on IPv4 address, it consists of 32 bits, we know. These 32 bits are divided into 4 groups. Each group contain 8 bits. That and all we know already. Here we say the IPv4 addresses are unique. It is used to identify a connection of device to a network. With the help of that IPv4 address only, we know which device is connected to a network. So what is unique means? Unique means it is different from every other addresses within the same group. For example, in a group, some numbers of systems are connected means that is network actually, correct? So computer network, some more than two devices are connected. We can make it as a network here. So in this network, for example, PC0 and PC1s are available means here for PC0, we are assigning the address it as 192.168.10.1 and for PC1, 192.168.10.2. So here we are assigning two different addresses for each and every device. It is unique. So 10.1 is for PC0 and 2 is for PC1. So if both suppose if we are assigning same address to two PC in the same network means it is very difficult to currently sorry, it is very difficult to identify the system you are for which system we are transmitting the message. So for that purpose, we are differentiate the address for each and every PC. Therefore, IP addressing is designed so that the addresses are assigned without conflicts within the relevant network. On one more point here, we know the IP addresses are unique. It does not mean that the same private IPv4 addresses can never appear anywhere else. But it can be used in the same address, it can be used in private networks, some other different private networks, it is possible to use the same address here. So this is unique. So unique means that is for each and every PC, the addresses are different. That is unique. What is meant by universal? So universal means the IPv4, it is a standard addressing system used across interconnected IP networks. For example, different manufacturers may produce different devices like computer, smartphone, router, server, printer, anything. So for each and every devices we want to communicate means it is with the help of that IPv4 address only. For example, a computer from one manufacturer, this is one device, and a router from another manufacturer, this is one more device. It can communicate using the IPv4 address. So this is unique and universal. So two devices on the internet can never have the same address at the same time. And also the addressing system must be accepted by any host that wants to be connected to the internet. Next, the notations are two notations are here. One is binary notation and one more is decimal notation. Already we know the difference between binary notation and decimal notation. So binary notation, it is a 32-bit. Here we are using only zeros and ones in each and every octet. 4 octets are there, so total 32 bits. Each octet contain 8 bits. There is a space between each and every octet. This is first octet and leave some space. This is second octet and leave some space. So similarly, how to write the binary notation here, and each and every octet contains the 8 bit. Decimal notation means 4 number decimal representation with decimal dot separating the numbers. So for each and every number, that means for first octet, one decimal number we got. So after that we can put one dot. Similarly for second octet, that is one decimal number. After that we can put one dot. So in this way we can write the decimal notation. So this is the difference between binary notation and decimal notation. In binary notation we are using the numbers only 0 and 1, and in decimal notation the range is from 0 to 255. If we are saying the first octet is 255, means all the 8 bits are 1 at the time, then only here the first octet we can get it as 255, because here 2 to the power 7 plus 2 to the power 6 plus 2 to the power 5 plus 2 to the power 4 plus 2 to the power 3 plus 2 to the power 2 plus 2 to the power 1 plus 2 to the power 0. So we have to add all the numbers, we can get it as 255. So that means if all 8 bits are 1, means the first decimal value is 255. Similarly, we can calculate the remaining octets. Already I explained this in the first slide itself. Here one more point, uh, the IP address how we can write means there are two parts here. One is network part and one more is host part. The difference between network part and host part is the network part identifies the network to which the device belongs. Suppose one device here, this is one device 192.168.10.1, means it belongs to which network we can identify by the network part. And similarly, host part, it defines the particular device within the network. Which device is connected in that network, that will be identified by the host part. So this is network part and host part. So network part, it is assigned by global authority, and the host part, it is assigned by the local authority to a particular machine. So here in this example, 192.168.10.1 for PC0, 192.168.10.2. So here for this network, this is comes under class C type. So I'll explain the classes in upcoming videos. So this is comes under class C type. The first 3 bytes are used for network part and the last byte is for host part. Already you know the difference between network part and host part. Here both this PC0 and PC1 having the same network. From this itself we identified it, both PCs are belong to the same network. The host part, it defines about the device. So one is for PC0 and two is for PC1. So from this we can identify the host part and network part of the devices. So here there is one example, conversion. So how we can convert the binary number to dotted decimal notation. So this in this example, this is the binary notation they given. So for each and every octets, 8 bits are there. You know the position, place value of 1 here. So in the first byte, this is at 2 to the power 0 and this one is at 2 to the power 7. 2 to the power 7 is 128 and 2 to the power 0 is 1. So 128 plus 1, it is 129 here. And similarly, in the second octet, the ones are placed in the position 2 to the power 0, 2 to the power 1 and 2 to the power 3. So 8 plus 2 plus 1, it is 11. Again the third octet, it is similar to the second octet. So there is a same value. There is nothing change here. 2 to the power 3 plus 2 to the power 1 plus 2 to the power 0. And in the last octet, except 2 to the power 4, the remaining all the bits, it contains the value of 1. So 2 to the power 7 is 128 and 2 to the power 6 is 64. So 128 plus 64 and 2 to the power 5 is 32. So 128 plus 64 plus 32, this is 0. So leave it. And this is in the position of 2 to the power 3. So here it is 8. 2 to the power 3 is 8. And here it is 2 to the power 2. 2 to the power 2 is 4. And in this bit it is 2 to the power 1, it is 2, and here it is also 1. So it is 2 to the power 0. The 2 to the power 0 value is 1 here. 128 plus 64 plus 32 plus 8 plus 4 plus 2 plus 1. So the total of this value is 239. So in this way we are converting binary to decimal. Similarly, the second example. Here the first 5 bits are 1 and the last bit is 1. So 2 to the power 7 plus 2 to the power 6 plus 2 to the power 5, 2 to the power 4 plus 2 to the power 3 plus 2 to the power 0. We can add these values, we can get it is 249. Similarly, in the second octet, 2 to the power 7 plus 2 to the power 4 plus 2 to the power 3 plus 2 to the power 1 plus 2 to the power 0. So here we can get it as 155. And here 2 to the power 7 plus 2 to the power 6 plus 2 to the power 5 plus 2 to the power 4 plus 2 to the power 3 plus 2 to the power 1 plus 2 to the power 0. If we add all these number, we can get 251. So here in the last octet, last 4 bits are 1. So 8 plus 4 plus 2 plus 1, it is 15. So in this way, we are converting the binary to dotted decimal notation. If you want to convert from dotted to decimal means, either you can use the division method. For example, 129. If you are taking 129 divided by 2, the remainder is, what's the remainder we can get? 1. And again you can divide, or else you can use the place value. You can write all the 8 bit as 0 initially, and for 129 definitely the last bit it will come. So the last bit we can put it as 1, and the rightmost bit is again it is 1 because the value is 129 here. If we are doing that method also working here, that is binary to dotted decimal notation. I'll explain that in the next video. Thank you.